Roy DeLay with Rushville. I'm a service tech, mostly on the road. Jeff Dawson.
I work in sales out of Rushville.
We want to talk to you guys a little bit about increasing your planning uptime, some maintenance, some pre-season checks. Then we're going to get in a little bit of down pressure. And Dave, I know, has got some questions on down pressure we're going to try to answer. And we'll get into some things like that. Come on in, guys. They're limited. They're limited here, so give Jeff some company over there. We're going to start out with the row unit. Guys, the thing about it you want to look at is your parallel arms where your row unit mounts to the frame of your planter. Has anybody ever pulled in the field with hit a fence post or electric pole or something with their planter folded up? That's good. I've seen that happen. Guys, that bends that frame, bends them row units. Not only that, but you got to look at the bushings where those row units pivot. When those pivot up and down, they get wear. And what happens is if you go in the back of this row unit and you can shake that row unit from side to side and that whole thing's loose up here and it's tied up on the frame, we need to be looking at those bushings and the bolts to make sure they're tight. Because if that's walking around, then your rows are going to be crooked and things like that. We're going on back. We're going to talk about our gauge wheel arms and our gauge wheels. Guys, our gauge wheel arms, they wear. It's a wear item. It's always constantly moving. The thing you got to realize, a lot of people will set that gauge will be hanging down when the planter's in the up position, and you'll feel it, and it doesn't feel that bad. But the key is, though, you got to raise that up to the plant position and then see how much movement it has. When you got that up in the upper position, you got your blade against, and it's against your blade, that's where you check your play and your movement. With hanging down, there's pressure on it right there, but in the up position, that's where the important part is, because that's when it's in the ground, the same, you're planting, that's where you're setting your seed depth. So you make sure you have that adjustment checked when you got it in the raised position. Look at your gauge wheel arms, look at your gauge wheels. Since we're talking about the gauge wheels, you want to look, make sure you don't have cracked tires, broken tires. You want to make sure this lip is good on the side because that helps build up your firm seed bed and your seed trench is firmed up. If you got rolled edges, then you won't do the proper seed bed and proper seed trench. So check that out. Make sure your bearings are good. Make sure they're not loose in the wheels. Next we're going to talk about is our True V seed openers, our blades. A new blade is 15 inches. A wore out blade, discard size, is 14 inches. So you wear a ½ inch off each side and it's wore out, okay? There are shims that go on either side of it, and that's where you adjust in and out where your blade sits. I'll get into some more problems we get into when the blades are too small, but right now we're going to talk about the blades. Once you get the blades, you got to replace your blades, or if you're checking your blades, they may only be 14½ inches, so you can still get by with it. But the thing you want to make sure is your blade contact is correct. Where the two blades come together, we want an 1.5 to 2.5 inch contact point. How's the easiest way to measure that? We'll take a business card and slide in from the top till it touches, slide in from the bottom till it touches. We'll measure that distance between those two business cards. That's the easiest way to check that. And the reason you want that contact at 2.5 inches, 1.5 to 2.5 inches, if you're going down through the field and your contact is 3.5 inches, too much contact, what's going to happen? You're going to have too much resistance, and the blades could slow down and bulldoze instead of roll through the field. Okay, so we will make sure our contact's right. And then on the other hand, you've only got a ½ inch of contact. What's going to happen there? You get down in the soil, and these seed discs actually open up. And now instead of a V trench, we have a W trench. So we got soil in the middle. And where's our seed going to go? It's going to bounce and try to figure out where to go in that trench. So we want to make sure our gap is set right so we can get a true V depth in the field. Also on those blades, we want to make sure our scrapers are working correctly. Okay? If you get these these scrapers wore off, we're not cleaning the dirt back off those blades. Where's all that dirt going? Right inside those gauge wheels. If you get all that dirt stuck inside the gauge wheels or rattling around inside the gauge wheels, we're wearing that gauge wheel out quicker. And then fill up with dirt, we're not getting the right penetration we want because we got too much debris in the way. So make sure we're cleaning that out or got the scraper set right. As we're moving farther back on the row unit, we got through our gauge wheels, gauge wheel arms, the blades, the scrapers. Now we're going to go back on our closing section. On our closing frame, you want to grab the end of that frame and shake it side to side. It shouldn't move hardly at all side to side. If it's moving much at all, your bushings are getting wore out where that pivots. Okay? If you get one that's wore out and moving too far to the side, what's going to happen? You get off to one side, you got that tire running in your V trench, in your seed trench. What's it doing there? It's either shoving the seed farther down, or if you have a different type of closer on the back, it's got a star or a point or something, it's going in that seed trench and flipping the seed back out of the ground. So it's very important to make sure we're not wore out on those closing system. On that closing system also, it's bolted on with 2 bolts on the bottom of that closing system right up here. Okay? Also on that, those 2 bolt holes are larger than the bolts, so we can adjust that arm to get it centered. Very important. You want to get that centered in that row. You don't want it too far to the right or too far to the left. It's going to be like I said, when you had too much movement, you're going to be riding in your trench, flipping the seed out or packing the seed down in there farther. So make sure you adjust that. As far as adjusting, about the only thing you can do is drag it across the ground and see that your closing wheel is lined up with your true V trench. If you drive a short distance in your barn lot, you can see the trench easy. If you pull it out in the field, when it's dry enough, you can pull a short pass through there and just make sure it's adjusted right. If not, you can loosen those up and do a slight turn to them.
One note to that too, guys, is take that tension off of that when you're actually checking your movement. It makes a big difference because you'll think they're pretty tight, but once you take all that pressure off, it's amazing how loose a lot of those get.
Right. Very good. And check that tension arm. Go ahead.
Is there some way to check that in the shop?
Is there some way of checking that in the shop? There's no good way of checking it unless you're dragging the planter across the floor. Most guys don't want to make a mark on their shop floor because you try to square yourself up. You got to square that row unit up with the frame, and there's no good way of making a straight line unless you're pulling it.
You couldn't like put a yardstick or something down between the opening coulters
Well,
come straight back?
you could, but here's the problem you run into. You can take that straight line. You've only got 2 points. You've got your seat opener, you've got the closing wheel. You can make a straight line between 2 points, regardless how crooked it is. See what I'm saying? But if you were to drive it forward, then you see the line from your seat opener on the ground and know that your closer is on top. That's going to be the only trouble. It's hard to see that just sitting in the shop. You can eyeball it and get very close and put a yardstick and get very close. And it may be close enough when you get to the field, it may still be close enough. But the only way to really know for truly that you're centered is to drag it across the ground someplace. If you want to make a mark in your tool shed, that's fine too. I mean, I didn't tell you to do that, David. But no, but that's, and take your tension off. Make sure that tension arm adjuster works. Make sure that spring's not broke. And that should flex up. If you take the tension off, you should be able to flex that closing wheel up off the ground. Make sure it moves around that way. Next, we're going to talk about our chains, sprockets, drive shafts. The older planters all have chain drive on them, whether it be a chain drive off the wheel, whether it be a chain off the transmission, driven off the wheel over then your row units. Make sure those chains are pliable. Make sure they move. You get one rusted up, then it's going to slide across. It's actually going to walk over top of those sprockets. What happens when it walks over those sprockets? It jumps, it skips. You get misses in the field. You get doubles and get a lot of mess in the field. That's not uniform. So you want to make sure that's very smooth and the chain is loose and pliable. Same goes on the drive shaft. The newer planters, we're putting these drive shafts in here. Okay, you should be able to take that drive shaft and just turn it with your fingers. Turns real easy. Okay, if those turn hard, you got much resistance to it, then you've got buildup of something inside there. You can try to clean it. I'm not going to guarantee you're going to get a very good job cleaning it, but you can try to clean it and try to lubricate it. Don't lubricate with grease. What's grease do? Collects dirt. So you got to be careful what you use. John Deere does make a product that does not collect dirt. It's called Super Lube. Okay, it's a spray. It's a synthetic silicone-based spray. You can use that. But best thing to do is if you need to lubricate it, one end has a seal in it, the other end does not, so you can spray it in that end and blow it in with air. Compressed air can blow it in there. That helps lubricate. But the best thing to do, if you got much resistance in there, replace them. That's going to be your best thing to do. Because if you got much resistance and you try to penetrate an oil or try to lubricate it, that's a Band-Aid. So your best thing is replacing them. While we're talking about the drives, the older ones had the chain drive. Some of them drove off the ground drive wheels and had chains run up there. Make sure that tire pressure is correct. If that tire pressure is off, then it's going to change how fast your seed drives. It's going to throw your population off. Same goes when you got the transmission wheel that sets down on the ground drive wheel. There again, make sure both those tires have the correct amount of air pressure. Because if they're off, that's going to throw your population off. Now the newer ones were electric drive or hydraulic drive. Okay, it doesn't have quite as big a play, but tire pressure is still important for compaction and wear on the equipment. We're going to talk about seed meters now. On the seed meters, things we need to look at. We need to look at our seals, the one that goes around the hub, and we also have the seal that goes around the door. Okay, both those seals are a rubber seal. They're very pliable. They should be pliable. If that seal is hard, got cracks in it, got breaks in it, you're not going to seal up your vacuum. So you need to make sure those are soft and pliable. They're easy to change. They just pop right on. They stretch. They go right back on the hub. It's not a big deal. So it's very simple to replace those seals on those hubs and on those door covers. Second thing is on your row units are your brushes. You see on that lower picture there, the brushes. Make sure those brushes are smooth. They don't have gaps in them. They don't have holes in them. The bristles are missing. I've seen mice get in there and chew those bristles up, and now you got big gaps and holes in them. So guys, just inspect them, look at them, make sure they're in good shape. Next, we're going to talk about our seed discs. These are very important because we've got the vacuum on one side, we've got the corn or the soybeans on the other side. Those discs have all these small holes in them. That's where your vacuum comes through. Problem is we can leak vacuum. You look at this disc right over here, we got these big scratches. Okay, that's where your seals ride and your vacuum is on that side. Well, if we got a lot of big scratches in there, we're sacrificing vacuum. We got a leak, okay? So 3/64 is the depth that they recommend is replacement. When those scratches get 3/64 deep, we need to replace these discs. Now 3/64 is not very big, pretty small. So keep an eye on these, keep them smooth, keep them working well. Best thing to do is you get done planting it for the season, take these out of your boxes, clean them up with soapy water, dry them off, and then we're going to spray this graphite lubricant on here. It's a slippery graphite spray that'll stick to your disc. And the key to that is that lubricates it, it kind of seals it up so it doesn't rust, and then everything flows through it smoothly next year when you start planting. What's the best way to store these plates? Any ideas?
Controlled environment.
Controlled environment's great. Best thing actually, and also best thing to do is put them on a dowel rod. Hang them on the hub. Okay? A lot of guys will just throw them on the bench, throw them on a shelf. The problem is we're sitting on that center part of that hub, and then you throw something else on the shelf and it starts pressurizing them all summer and all winter. Now they start to warp, they start to bend. Then when you get it back out, you put it in a planter, it does this number. It's kind of hold vacuum. It's kind of hard to get the seed to flow right when you got a warped plate. So the best thing to do is hang it right there on the hub. on a dowel rod or something. That's the best way to store them. Also on these, you got all these little holes. Make sure they're clean. Make sure they're not egg-shaped or oblong. If we get too big a hole, then we got vacuum leaks. If we got a nick or something in the pocket where the seed sits, the seed's not going to stay in there right. It's going to fall out prematurely. So just inspect those, make sure everything is good on those. Some of these row units have knocker wheels on them. On those knocker wheels, we make sure they can roll smoothly, make sure they can rotate back and forth. We just want to make sure they're freed up. Next, we're going to show a short video of, it's a talc video. It says talc and graphite. The video is about talc, and then we'll discuss a little bit on the talc and graphite mix. So this will tell us quite a bit about the talc.
The proper vacuum level is certainly high on the list of importance, as is the use of talc. In a vacuum meter, talc helps by drying the seed, which is especially important with treated seed. If the seed is sticky, it can affect how the seed is released from the vacuum disc. If one seed drops off the disc immediately, and the next hesitates due to sticking to the disc, seed spacing is sure to be significantly altered. To know how much talc is needed, follow this rule of thumb. Just inspect the disc for seed treatment buildup. If you find buildup, use more talc. Although amount is important with talc, so is how it's applied or mixed with the seed. Simply dumping talc in on top of your seed is not good enough. It should be mixed in the bag or seed hopper to better coat all seed surfaces. For planters with central commodity systems or CCS hoppers, put in the talc as you fill the tanks. As always, use talc with treated seed per the Ready to Plant guide and make sure to double the amount when required. For example, any insecticide-treated seed requires double the talc as a starting point. How much does talc really matter to the planter's performance? Well, incorporating the correct amount of talc by the recommended methods should produce a 5 to 10% improvement in acceptable spacing at the seed tube exit compared to seeds planted without talc.
That's a nice little intro to the talc. The thing we need to know about talc is it dries the seed back out. When you get the more seed treatment on these seeds, the more humid the day, the stickier that seed is. So the talc dries that back out. Those are using just the planter boxes, and talc is great for that. The CCS, the central commodity units, we really recommend our 80-20 talc graphite mix. One, the talc is drying the seed out, so it's not sticking to things. And the graphite, what that helps is lubricate the seed so it flows through the tubes better. When you got everything in the box right there, you don't need to flow anywhere other than through the meter unit and down to the ground. But when we got our CCS, we got to blow all that seed clear out to the row units. So that's where the graphite's going to come in to help. So that's why we're recommending the 80-20 for that. How many of you guys are using the 80-20 now? A few of you are good. Does it seem to help any, or versus the talc in the past only? Yes and no.
I think sometimes we use too much of it.
Use too much?
Our manifold seem to be overfull.
Okay.
But maybe that's just common.
And that's a very common perception. A lot of guys use too much, or they probably do, because if you look at the bottom of your hoppers, you see a lot of talc down at the bottom. The other thing is, the key is make sure you're actually kind of blending it as you're filling. A lot of guys used to just fill the bins up and then they put the talc on top. Make sure we're trying to put some as you're filling so it kind of blends in there. That'll help out too. That way it kind of flows better with it. So next we're going to talk about our seed tubes. Guys, there's not rocket science to them at all, but the thing about it, when you run worn out blades, what's going to get worn out next? The seed tube is going to be a ground contact where it shouldn't be. So make sure we keep our blades right, make sure we inspect our seed tubes. Nobody's ever backed up with the planter in the ground yet, have they? When that happens, these get filled up with mud and then you got to clean them out. Yeah, and it breaks them. But the other thing is if you got a rough seed tube, it's cracked, it's broke, got debris in it, what's going to happen to that seed is it's going down through there. And it's bouncing and tumbling and rocking around in there. We want that seed to slide right down that tube into the trench. We don't jump it or bouncing around. So make sure we keep our seed tubes clean and smooth. I'm not going to get a big preach about row cleaners. The biggest thing I want you guys to understand, no-till holders and row cleaners still need to be adjusted properly. When I say properly, your no-till holders, they need to be shallower than what your seed trench is. Okay? You don't want your no-till holders going deeper than what you want to put your seed. So you make it shallow and let your seed openers open that up where it needs to be. The second thing on row cleaners, we just want to move the debris out of the front of the row. We don't want to make a furrow. We don't want to dig it deep. Because what happens when we dig a furrow and make it deep, we get a heavy rain a week or so later, all that fills in, and now our seed's 3 and 4 inches deep instead of 2. So we just got to be careful how we adjust them. There's several different makes and models and ways of doing that, but the proper thing is make sure we adjust it properly. We don't want to make a big trench. We just want to skim it off there and move your debris. Depends on the amount of debris you have in the row that you want to clean out. Okay? If you adjust your seed depth, then you want to make sure your holders are readjusted, because your seed depth is controlled by your gauge wheels. With your row-mounted row cleaners, that will change that position. So make sure you readjust those when you change your seed depth. It may only take 1 or 2 notches on your seed depth, but that'll make a difference on your row cleaners too. So make sure we're adjusting that.
What about your example here is floating row cleaners?
Okay, floating row cleaners, they've got the wheels on there that will help keep the depth that you want, but they're still, they still got to stop where they go down on those too, but they float more with the contour of the ground. So it's a little less adjustments for you. That does make a difference. Jeff's going to get into downforce, margins, and all that fancy stuff that we have on these things. It's also very confusing. So I'm going to let Jeff have the reins, and we'll see what we can come up with here.
So downforce, guys, as important as what you're going to hear in a lot of the other classes as far as spacing and everything else, it all affects yield. If we don't have the proper downforce, we're not getting the proper seed bed and the even emergence that we're actually out to get. I mean, when it's all said and done, we're actually looking for something a little similar to this versus something that looks like that. A lot of times we all know what happens, especially come harvest. You're going to watch your yield monitor and you know what all those little plants look like when you run across the field. So we're trying to get ourselves to a consistent depth so our seed is put in the same place. We get an even emergence regardless of whether we get where we need to be on that. There's several different ways that we get there. First way, and it's been around a long time, we've got the spring downforce. The spring downforce has got your 4 adjustments on there. You're going to do the actual setting of your springs the same way you would, whether you're pneumatic or you're active. The same process is done to achieve that downforce that you want. A little more current to now is we get into pneumatic downforce, where we've got our airbags. We can watch those on our monitor. We can change them going down the field, try to adjust to our field conditions without having to get out like we did on the springs. You still got to have a good basis on whichever system that you're currently using. Then we get into active pneumatic. And the active pneumatic, what it's going to do is you're going to set that margin, and then the computer and the gauge wheel sensors are going to actually be able to monitor how much downforce we need to maintain the margin that you've set. It hasn't got smart enough yet to determine margin for you, but it is able to maintain that margin that you put in there. We're able to do that with the compressor that we have now with active pneumatic. We get into a hydraulic driven compressor. We get into a larger holding tank, which If anybody's got the pneumatic or was around the pneumatic, we had a little electric compressor and a small tank. Was great because you didn't change it all the time. It was fine. It was a little slow. But now that we've gone to automatic and it's changing up and down, going across the field, we've got to be able to maintain a little faster. Brought up in one of the classes prior to this was one of the complaints was it maybe didn't react fast enough, or maybe when they got into worked ground, then they ended up with too much or empty airbags and it wouldn't fill up fast enough to compensate. There is one solution that we're trying to do and we're going to try it this year on a few rows to see. There's an up-force spring that we can put on there, and the idea behind it is we're going to try to put that up-force spring on to make that airbag always have something in it to compensate. So when he gets, this particular person's in an area where they've got really light soils, and so he's trying to maintain a little bit of pressure on those airbags all the time so it doesn't have such a long reaction time to get back to. So if you're having a little bit of an issue with that, with it bulldozing or not getting back down at enough pressure, I mean, we can do some things to kind of tweak it just a little bit. So Deere does a really nice job of explaining margin, probably better than I do, so I'm going to let them do the talking on this part of it. And remember, this margin, like I said, it doesn't matter whether we're talking pneumatic or active pneumatic. It's the same principle. It gives us a place to start, and the actual testing or sampling of our pressure goes for the spring as well to maintain the pressure that we want.
This video is designed to help you better understand row unit downforce margin. Understanding margin is key to optimizing your planter for both active and non-active downforce systems. Downforce margin is the amount of additional downforce applied to a row unit above and beyond what is required for penetration and to achieve full planting depth. The John Deere SeedStar XP monitoring system measures downforce margin with load sensors located in the row unit gauge wheel depth control handle. Setting downforce margin properly will ensure that the openers achieve full planting depth and that the gauge wheels provide enough firming of the seed furrow to prevent the walls from collapsing. Proper downforce margin also prevents excessive row unit bounce, which may cause uneven seed spacing. To properly set the downforce margin for your conditions, follow these steps. Plant a small test strip. Note the high, low, and average margin value in the lower right-hand corner of the downforce run page. Stop the planter in the lowered position. Exit the cab and check to see what the seed furrow looks like at this setting. Do the walls of the seed furrow look firm but not compacted? Is the seed planted at a consistent depth? Are the gauge wheels firming the furrow correctly? In this example, the correct downforce margin is being shown for the field conditions. Notice how the seed is planted at a consistent depth. The walls of the seed furrow are firm and not crumbling, and the gauge wheels are firming the sides of the furrow correctly. If a field check confirms that downforce is correct for your field conditions, you have determined the proper target margin value for this field. The average and target margin should now be nearly equal. The function of the gauge wheels is to provide depth control and firm the soil against the openers to create a defined seed furrow. There are many signs when downforce margin is not properly set. Too little downforce margin will prevent the opener from planting at a consistent depth because the gauge wheel may intermittently come off the ground. Too little margin may also cause the seed furrow to collapse in front of the seed drop, resulting from too little pressure on the gauge wheels. In this example, too little downforce margin is being shown for the field conditions. Notice how the sides of the seed furrow are crumbling into the seed trench and the gauge wheel tracks are uneven. Low margin may also cause overall row unit ride quality to be poor. The gauge wheel should just barely be able to be turned when in the planting position. If the gauge wheels spin too easily, downforce margin should be increased. If the gauge wheels cannot be turned by hand, this is a sign the downforce margin may be too high for field conditions. If there is too much downforce margin, the side walls of the seed furrow may be compacted. The sides of the seed trench may appear slick or smeared. In this example, too much downforce margin has been set for the field conditions. Notice how the sides of the seed trench are compacted. The gauge wheels also may leave deep tracks or ridges in the soil from too much pressure. If your field check confirms that the downforce margin target is incorrect for your field conditions, you will need to either increase or decrease the row unit downforce setting to compensate and perform the field check again. Watch Using Set Point Control or the Using Active Pneumatic Downforce videos for more information on operating your system.
Does that make sense, what they discussed in there, and that where it applies to either spring or set point or active pneumatic? It's all the same process. And I know nobody wants to do it. What happens is we get late in the planting season, or we plant for a week and then it rains for a week and everybody's back in a big hurry. But we all know, whether we want to admit it or not, those field conditions have changed, and wherever that planter was where you stopped last week may not be the same as this week. Take an extra few minutes, lock up a couple closing wheels, do this test. It pays. That extra, even if it takes you half an hour, you can't substitute getting out and actually checking it versus what yield drag you could get by either too much downforce or not enough downforce and an uneven emergence or worse. So just to kind of recap on that video, that downforce is the actual amount of pressure we're putting on there versus the margin, where actually the difference between the down pressure and actual how much we actually have on the gauge wheel. So in other words, it's easier to see margin on set point or active pneumatic because you can actually physically see it on the screen because it's going through the sensor, if you've got XP, through the gauge wheel sensors. I'm just reiterating here what they talked about in the video. If we don't have the right down pressure, we're gonna get either loose sidewalls, hatchet roots, uneven emergence, all the things that they discussed in the videos. Quick overview of the theory of the operation. Once again, downforce. I keep repeating this because it's so important. It seems to be the one question we get the most of every year when springtime rolls around. What do I put my margin at, or what do I put my downforce at? There's not a textbook answer to that because everybody's different. And I know that sounds like we're avoiding the question, but I can tell guys to start at 100, but I've had it happen to me before. Tell them to start at 100, they put it on 100 and they're in a hurry and they just go and they plant the whole thing. And sometimes it doesn't work out so well. So it's just a starting point. Depends on your soil conditions, tillage practices, moisture content, so on and so forth. But I'm going to put a lot of downforce on harder ground. In this example, actually the next one's a little bit better. These are kind of fictitious numbers, but they're easy numbers. I'm slow at math, so this makes it easier. But they're showing the weight of the row unit, 100 pounds. We know that a 3-bushel box full of seed is going to weigh more than 100 pounds, but easy numbers. So if we had 100 pounds here, we put 150 pounds of downforce on, and it takes about 200 pounds to get into that soil. Our margin then at that point is 50 pounds. So in active pneumatic, we would set our margin at 50 pounds of margin, and our down pressure would change to maintain that margin of 50 pounds. It's going to change again field to field. Go ahead.
Is there any equation for doing no-till for measurement?
You mean a specific number type of thing? Not so much. No, because there's so much variance. The best thing I can tell a person, especially if you have XP monitoring, watch your ride control. It tells you a lot how much those units are bouncing. Watch how much your margin or downforce is varying. And once again, get out and look. I know everybody gets tired of hearing it, but it's until Deere comes out with the technology that we've got a in-furrow camera, which they've come up with cameras with everything else. The only way to do it at this point is to get out and look. There's really not much substitute. Someday I'm guessing that infrared cameras will exist. They can do some pretty amazing things, so we can probably tell someday down the road. Maybe that's my $1 million idea I just haven't explored yet. But this just basically shows us some of the differences between set point pneumatic downforce versus active pneumatic downforce. The take home from this, if you have set point, you're going in and you're actually putting in a margin that you want to try to maintain. Your margin is going to change. Let's say in this instance it's 30 pounds. As your margin changes, that number changes. The only way to get back to 30 is to actually change your downforce manually. Increase your downforce pressure, decrease your downforce pressure. On an active pneumatic, we're going to put that margin number in, and it's going to automatically change our downforce to try to maintain whatever that number is for you. Both equally as important. Without the proper margin number, whether it's doing it automatically or you're doing it yourself, it's still equally the same one.
Is the unit still designed for the parallel arms to be running perfectly horizontal?
Yes.
So if they are, I mean, because we've had a few times when Dan was trying to run the beam planner, where the computer and everything looked like it was doing about right, but they were running down about 10 degrees. We always thought we had too much pressure on it, but it all looked like it was doing a good job, but then you're flipping your row unit.
True. Well, and you want it as parallel to the ground as possible, especially the more options you have on there. You know, if you've got fertilizer and you've got a row cleaner and you've got a no-till color, I mean, the longer we stretch that out, the more it is, whether we're digging or taking off the back end. But, you know, you're only going to be able to tell what it's doing by looking that way. So in other words, if it's pointed down, it's going to put more pressure on, because it's going to take more to put the gauge wheels into the ground than it would if it was level. Does that make sense? So it's still going to whatever margin you put in, it's still going to do it.
So do you think we had something else set right now?
It could be.
We were kind of fighting that last year.
It could be. I mean, if your parallel arms, if your tilted planer's tilted forward, maybe row tillage is getting a little much, or maybe we're even back. Yeah, I've seen it where we're back too far, and then we think when we're looking at the front, well, my row cleaners or my no-till color's not getting down on the ground, so we put more down pressure on it. Well, if the planer's tilted back at those closing wheels, by the time we get to the back, we're putting just even more pressure onto that. So level is definitely big. Tire pressure, as mentioned earlier, that goes all the way back. I don't care if you got a 7,000 6-row. Tire pressure is huge. One of the key points if you've got XP monitoring, one of the things when you're doing that test to try to establish where your margin is, if you've got active pneumatic, uncheck that box to start with. The reason being is if you're out there trying to do that test, you've locked up your closing wheels, and you leave that checked, whatever set point that is, whatever margin you've put in, that down pressure is going to change all the time, and you're going to be chasing your tail. You just can't get there from here. If you uncheck that, then at that point you're working with a constant downforce. At that point, then you can establish where your margin needs to be. When you get back and you're done, if you have active, make sure you check that again, because that's why you got active, to let it do it itself. But without that box checked, you will not see this little green symbol up at the top. This means that active pneumatic is working. Whether you got set point or you got active, you're going to show your downforce and your margin set point over here. Goes back to what I said a minute ago. Reiterate, there is nothing more important than being able to get out and look. I know everybody gets in situations where we got a lot of fall tillage done maybe one year, maybe got half of it done, and we don't change the planer as much as we probably need to as far as downforce goes, and your set point and your margin. Different field conditions, different tillage practices, so on and so forth. Guys, is there any other questions on set point and margin? I know I kind of went through it kind of quick, but as we get into that, we can get down in the weeds pretty deep with standard deviation and all the other things that my engineering degree expired, so it doesn't do me good.
At the conclusion of the video you showed, it mentioned 2 websites to go look
Yep.
at. Where are they?
So if YouTube video, John Deere doesn't really have it out there on their website, but John Deere did a YouTube video. If you Google or go onto YouTube and do SeedStar XP downforce, understanding downforce and adjusting. And I can write that, I'll give it to you. But I know that sounds kind of silly, but there's not an actual link to it. But what it'll do is it'll give you all three. Because on YouTube, if you've been on there much, you could put in John Deere all you want, but anybody and everybody that's ever done anything for John Deere pops up on YouTube. So there is 2 on John Deere stuff on John Deere's website, ready to plant videos. There is some of that on there as well.
Is the difference between the XP and the ExactEmerge?
Yes. It's the same concept, but your different system on the XP versus the ExactEmerge.
But the video's still going to, the concept's still going to stay the same.
From a standpoint of margin, is yes, that doesn't change, and that goes all the way from spring all the way up, as far as what we do there. But your monitoring system's a little bit different with the ExactEmerge, the way it shows on your screen. Yep. Well, guys, we don't want to make any of this a sales pitch because we know that's not why you're here. But one thing I did want to show you, this is kind of a neat short video that the Deere has that shows some of the things coming up for planters, some of the new technology coming, and there's a few things at the beginning that probably don't necessarily apply, but after that it gets into some really kind of cool stuff that's coming down. No in-furrow camera, but something close.
A new day and age in planting has emerged. It seems like only yesterday we brought you new equipment to raise planter performance to heights never imagined. Now, imagine everything we didn't bring you. And we bet many of those features you just thought of are here today. Introducing all new planter solutions from John Deere. From cab to closing wheel, we've enhanced all facets of our lineup. Like offering ExactEmerge row units for the first time ever on our popular 1725 CCS, 16-row 30 model, and select models of our highly productive DB series. Not to mention the DB series now comes equipped with our standard new MaxEmerge 5-row unit, if you prefer. Have a need for speed, but no need for a new planter? That's fine. If you own certain models of our 2011 or newer John Deere planters, you can now add the new ExactEmerge Retrofit Kit and get all of the superior agronomic advantages on your current bar. We're talking the industry-exclusive brush belt delivery system, high-performance vacuum meter, redesigned double eliminator, dual electric motors, and more. It's all there, ready to give you true yield maximizing benefits to help achieve even emergence, correct plant population, uniform spacing, and improved productivity within the optimum window. That goes for corn growers, soybean farmers, and now, for the first time, we've built new crop plates to bring ExactEmerge to the cotton, sugar beets, and popcorn markets. That's just the start. We'll add more crops in the near future. Of course, there's more to having a successful planting season than the row unit. There are other considerations, such as navigating around tight turns and managing the appropriate weight. That's where 2 all-new features come in: curve compensation and frame weight distribution. Curve compensation lets you maintain population on curved rows, from the inside row all the way to the outside. Trust us, if you have a larger planter, this was built with you in mind. As for frame weight distribution, it's available on our widely popular 24-row 1775 NT CCS machine. Frame weight distribution spreads the weight more evenly across the planter to take weight off the center frame tires, helping to avoid pinched rows that can negatively impact your yield potential. A definite plus in high moisture soil conditions. Like what you've seen so far? Well, there's more. Announcing new vacuum automation. Monitoring and making adjustments to vacuum levels is a thing of the past. You get precise and continuous seed placement without having to constantly check. That's a whole new level of confidence. Speaking of confidence, wouldn't you feel better knowing your row cleaners are adjusted properly at all times, particularly in heavy crop residue? Now you can. New Easy Adjust unit mounted row cleaners take adjustment time from minutes down to seconds, and it's controlled from the convenience of your cab using 3 quick and easy presets on your 2630 display. Even greater productivity can be found with the new fertilizer and granular chemical system, which allows you to apply one or both products in furrow, all while planting. You can deliver as little as 3 and as much as 8 gallons per acre, based on your field conditions or preference. Put it all together, and what you have is not just a better portfolio of planter options, but arguably the best. More precise, more productive, more potential in your field. It's all new planting equipment from John Deere. Nothing runs like a Deere.
Meg, got any other questions? If you want those videos, I'll write that links down for you if you'd like. That way you can see those. Yep, no problem.